Problem number 4, find critical points of f of x, y and classify them. Okay, let's take partial derivatives here. Partial derivative with respect to x is going to be, okay, this is only a term with an x in it, so negative 2xy. Partial derivative with respect to y will be 9 minus x squared minus 9y squared. Okay, so what does this show us? We need both of these to equal 0. From the first equation, negative 2xy is equal to 0, we see that we have two cases. X is equal to 0 and y is equal to 0. If x is equal to 0, now we need to look at the second equation here. That would give us 9 minus 0 squared minus 9y squared is equal to 0. 9 is equal to 9y squared. 1 is equal to y squared. Y is equal to plus or minus 1. So this gives us 2 points here. For both of them, x is 0, 0 comma 1, 0 comma minus 1. Now for the y is equal to 0 case, what happens here? 9 minus x squared minus 9 times 0 squared is equal to 0. Plug in y is equal to 0 here. 9 is equal to x squared, x is equal to plus or minus 3. So this also gives us 2 points, 3 comma 0, negative 3 comma 0. Okay, so we have 4 points here. Now we have to classify them. We do that with the discriminant. We need the second derivative to calculate the discriminant. So f sub xx, f sub xy, f sub yy. Okay, second derivative of this with respect to x will be negative 2y. Now take the derivative of this with respect to y, and that will give us negative 2x. F sub yy, take the derivative of this with respect to y, and we would end up with negative 18y. So our discriminant is going to be fxx times fyy, negative 2y times negative 18y, minus f sub xy squared. And so this will be, let's see here, 36y squared minus 4x squared. So, okay, let's list off our 4 points, 0, 1, 0, negative 1, 3, 0, negative 3, 0. And we plug in these values into the discriminant. X is 0, y is 1, that gives us 36. X is 0, y is negative 1, that also gives us 36. Y is 0, x is 3, that gives us negative 4 times 9, that also, now that's negative 36. And x is negative 3, y is 0, plug that in here, that also gives us negative 36. So these two, the third and the fourth, we can see that the discriminant is negative. Negative discriminant means saddle point. And for the first two, the discriminant is positive, that means local max or local min. We just need to calculate now f sub xx there for those 2 points. So f sub xx, the second partial derivative with respect to x, is going to be negative 2 times 1 is negative 2, and negative 2 times negative 1 is positive 2. So in this case, this is negative here, so this is going to correspond to a local max. This one here is positive, this corresponds to local min. So that is problem number 4.